Welcome back to the channel, and thank you for tuning in, as always, to Johnny's Motorized Bicycles. So, what do we got going on today, Johnny? Well, funny you should ask me, potatoes. Remember I said I'm the meat, you're the potatoes? Anyway. So, what we got going on is one of my maybes, maybe I'll call you, actually called me. Believe it or not, I got a call. So, we're going to build him a motorized bike. How are we going to build him a motorized bike? That's a very good question. Well, I'm going to take a whole bunch of parts and I'm going to turn it into a motor. I have two new case halves, new cylinder head. I got to get a head, maybe I'll paint it. It's going on a black and orange mongoose bicycle. I think I'm going to take this motor's guts and use the guts out of this motor because this motor is really new, and that will allow me to put together a really solid little runner. Like, this isn't something I'm going to be, balancing. I'm just going to put it together. So I'm going to run with this because I know it's going to be a nice smooth runner for him. It's going to be really solid. I would love to keep it for myself. Someone's paying me to do this, so I'm going to give them the best I can because I think that's only fair for a bought product. That's why I'm learning to do the balanced cranks, just so I can pass it along to the people that end up buying them, the high-end versions, not the basic motors. I believe this is all the black hardware I have right here. So let me start breaking this down. Let me get into it and we'll see where the port timings start at stock. We're not going to do a lot of work to it. We're going to keep it mostly stock. I'm going to clean it up. I am going to jazz the motor up a little bit to give it a little more grunt and power, but we're not going to go crazy in any means. He's looking for just a good, reliable runner, and that's what I'm going to give him. The fella's name that is getting it, his name's Paul, but he likes to be called Bear. I'm gonna measure it without a base gasket because if I'm building this motor, I am going to do the whole ultra gray like I prefer. I think it works better than put a gasket in there. For now, I'm not putting the case gasket in. I will do that later if needed. If I don't need it, it depends, because in the other case, this had play, lateral back and forth. With the gasket, it will only increase that. Now, if I keep the gasket out and I don't have any lateral play, I don't have to put a shim in. I'm gonna run with no gasket and just do ultra gray. So as it sits, piston is contacting the head. Now this doesn't bother me because I have no head gasket in. So I think with a head gasket, that wouldn't happen, but I'm gonna guess that the squish is still gonna be too tight, which is okay. I still have to surface the head. I still have to surface the cylinder. Still have to surface the actual case. Worst case scenario, then I have to run base gasket. Not really that big of a problem or a big deal. On a stock build, it's really no problem. I just prefer to run no gaskets. Side note, since we're talking about gaskets, I have zero end play. This way, back and forth, I have zero. What else do we have going on? Good thing you asked. I got all the numbers so I can start doing this. If you can see in there, can you see that maroon-ish pink line? It's about where I need the top to be. As far as the numbers, stock, we have intake is 122 degrees, transfers is 110 degrees, exhaust is 140 degrees, and blowdown of 13. I'd like to get the blowdown to 23. Which means I gotta raise exhaust 10 degrees. Even if I raise the exhaust, it's only gonna give me 160 degrees of duration, which is honestly not bad. So I'm okay with that. The intake, I am gonna open up a little bit more. I'm gonna skirt the piston. I'm not touching the transfers. This is an injected mold, so the transfers are super clean. I don't think I'm gonna touch them because I don't wanna go crazy. I want a higher intake than I do transfers. The intake's not going to go much difference though. It's not going to be much higher. We know what we're working with. We know what we're going to. I have to tap and thread the case in the back and in the front. I have to notch this, notch that, fill the oiling holes. I'm going to see what I got to do with the case. I don't think I'm balancing, though I'm thinking, I'm not going to lie, I have been thinking about balancing in the crank just because, but we'll see. That's where we're at, that's where we're going. The case was 6mm, tapped it out to M8 1.25s on the back and the front. If you look here, I couldn't get over any farther without going through the wall, so I had to catch slightly in this hole that was already there. I drilled it twice as deep, so it's going to be more than enough thread. I'm not worried about it holding on. I'll also Loctite it not to have any issues. And this one here, you see where the other hole was, I got that one completely over on the side. In the little lookout on top, you'll notice a line there and a line right there. What that's going to be is, this is way too small. This is for like an old school steel frame. The mongoose, as you know, most mongooses, they have very large down tubes, so I'm gonna grind this out. So I'm only gonna be able to take it so far. This one is away from this hole completely. So I'm gonna end up coming over a little more on this side and then ovaling it out to match up. I'm just gonna get it as close as I can. It's a tight fit, so I need it to mount to the motor itself. I can't put the backing plate on. The piston, it's got a lot of side to side on this one, so what I want to do is try to make some kind of spacer in there on both sides of the connecting rod and put it on the wrist pin. Hopefully I can come up with some thin spacer that would work and just basically keep it centered and from going a lot of play. I don't mind that it has the play because obviously the cylinder keeps it straight in the bore, and so does this. But what I have a problem with is as it goes up and down, you see how the bearing is right now? The bearing can do that, and that's all I want to stop. I want to stop the bearing from being able to walk left to right, so we'll see. So guys, what I want to show you real quick is I did all the rough port work except for one half of the case. The reason I didn't do half of it, I want to show you the before and after. So this is the completely stock side. Now I didn't go in and change transfer duration, but I'll show you what I did do to the transfers. You can see where I ground down this fin just slightly. Okay, if you look at the difference in the variations, and I'll show you why in a second. And then here I ground it down, and I even ground into the transfer. There was a slight lip it was going to bump up against, but there was more than just that. So on the case, again, just the rough. This is the edge I took down, and I'll show you why. Now I took it down. There's still plenty of meat to grab onto. A little bit here, in the corner a good bit, and then down here I feathered it in. Now let me show you why I did that. I'm hoping you can see in there. Now there is a little shelf still right here and here, but it doesn't hit it. It's something that goes past. Now over here, if I didn't take all this down right here, it was sticking out here into the transfer. It would have definitely obstructed the flow a whole lot. Now, I've never done this before on any other motor. I don't know if any other motor was like this, to be honest with you, where I felt that I needed to go in and shave it down. But if I didn't do this, over on this side, it would have been a huge shelf the air would have been hitting. Now, just so you can see difference. So this side is obviously not touched, and this is the side that I did touch. I'm not sure what's going to be the best view for you here, but it's hard to tell because this is the side that I did, but if you look, like this is this side. So if you look real carefully, you can see how much of an edge is here compared to how much of an edge is there now. It's pretty flat. It's, you know, it's a pretty easy transition. So all this was just jamming into the transfers because the transfer wall is about here. I'm gonna show you on the side. See this edge that I ground down? Look how it sticks into the transfer. I'd say that's a good third of the transfer is covered. It's a problem is what it is. I basically put a line here with the marker, and then I already know that this whole thing all the way down to here, so what I do is I just end up feathering it all the way down. This is going to be much harder to see on this angle. Down in here, so that lip is going this way, which, you know, I hit a shelf this way, which isn't a problem because the air is going up. So it goes right over that. If anything, it makes it a little more turbulent, not a big deal. This whole transfer on this side is covered by the actual cylinder here. So it's a big shelf it hits from the secondary transfer. So the secondary transfer is getting restricted a tremendous amount by the cylinder itself. So that's where we're at with the grinding. When you just look at it with an eyeball, it doesn't look that much. But believe me when I tell you, that little bit I think is really gonna make a difference for the performance and the grunt that this little guy has. Okay, so for the back, all I did was drill the holes out, retap them with proper threads and depth. The front was a little trickier. The mongoose has a very large down tube. This is the holes they originally had. Now, I got as close to this edge as I could, but to be honest with you, I'm not at all worried about it. If I was, I would not use it. So what I did though is you see this big mark. I went outside, originally this is the line here and this is the line here where I need it. I went out and test fit it. This wraps around perfectly on the down tube, which is wonderful. Biggest problem I'm gonna have now though is, let's be honest, I have no way to attach this. I don't have a bracket that's big enough to go, oh, I could make one for sure, which I'm gonna make one. But the big problem, the thing that I'm gonna have the biggest problem with, let me use this bubble blower here, maybe if it will work. Yeah, this should work. So this is about the size of the down tube, you know, give or take. It's just a kid's bubble blower. Actually, it's smaller. But if you look, you kind of see the hole? It protrudes into the side, and same with this one, into the side of this tube. Well, mind you, this tube is actually smaller than the actual down tube, so it's actually smaller than the tube on the bike. So what does that mean? I can't run a stud straight because it's gonna go into the bike's frame, and I'm not taking this fella's bike and shaving it down to fit the screws or nothing like that. So what I did, I came up with this. There's a little bit more work that needs to be done, okay? So this little bracket, but what this does is once I get this on here exactly where I want it, what I'm gonna do is I'm gonna cut on an angle from about here down. I basically just wanna take this angle and continue it, okay? Does that make sense? So there will still be plenty of bolt holding it on. These are grade 10.9 bolts. They're stronger than grade 8, okay? So these bolts are more than strong enough to hold this. If anything's not gonna hold, it's gonna be the aluminum threads way before the steel does not hold. So I'm not stressing any of this. This is gonna be perfectly fine and safe for him. Not to mention, he's not making a speed racer. He wants something just reliable, and that's what I'm giving him. Something that I know will go with the test of time. So I'm just gonna cut these in an angle to make sure the tube fits in there nice. I won't just hack it. I'm gonna end up doing a bunch of pre-fits, pre-fit, cut, pre-fits, because I want to take off as little as possible. But that's what I'm gonna have to do. Now the reason I'm going to all this length, because I 100% could just get the universal plate that is just a plate, and then you use the U-bolt to go into it. The reason I'm not doing that is because it raises it up. Just to get this thing where I need it is taking quite a bit of work just to get in the ballpark to be able to mount it, let alone the port work. Now the port work and the numbers, I'm gonna get the final numbers in a little bit here. I'm gonna start doing finishing port work. Basically, I gotta sand down the exhaust. As far as the intake goes, everything else I'm doing, I'm leaving rough. I'm not smoothing it out at all. I think you get better performance out of all your intake ports, transfers and everything. You get much better performance if you leave it rough. I don't have any evidence to prove 100% that you do outside of a butt dyno, I guess you could say. And my butt dyno has been calibrated, and it definitely tells me that when I have the rougher texture on the transfers, on the intake, stuff on the manifold, I get slightly better performance. I think it has to do with the air gets so turbulent that it atomizes the fuel even better, so that you don't have a bubble of fuel, you have a gas, like actual vapor. So that's why I do that. But the exhaust, 100%, you get noticeable performance by polishing it. So I'm going to polish that. I still got to finish this side, and then I got to do mating surfaces. Okay, I just did the things that I do to every piston. It started off at 71.13, I think, and we are 69.15. So I have washers that fit perfectly. Look how good that fits. And they just happen to also be the exact same size as the top of the connecting rod. So I'm super okay with that. That's what I'm gonna use for spacing. Now, 4 washers is definitely what I need. Problem with that is the washers do not fit. Now, if you look carefully, the 2 that are next to each other here, they don't look like they're touching 100%. I'm pretty sure that the washers, because of the shape of them, one side's sharp, one side's kind of rounded, I would put money that they're punched out of a big sheet of metal, which means they have, even though they don't look it to the eye, they probably have a slight bow to them. So what I'm gonna do is I'm gonna sand them down. I got them ground down, and they fit in there nice and keep the bearing centered so the bearing can't go left or right and fall outside of the connecting rod, which would obviously be right here, and then we'll keep it centered. See how it goes. It does add a good bit of weight. I just measured it, and it was 98 point something grams, but that's with the wrist pin. Before I didn't measure with the wrist pin, I just measured the piston itself. I am thinking about balancing that crank. I was really debating on doing this or not, but because I added those washers to keep the bearing from moving around. Unfortunately, it is not perfect, but it is better than stock. I originally wasn't even going to do it at all, so is it really that big of a letdown? I don't know. I don't really think so. I'm just going to let it ride because it is basically a stock motor. So this is what I did. I drilled a small one all the way through. I center punched all of them with a small bit. These two are the stock holes, whatever. These are the ones I did. You saw it turning. It turns so much slower. It's almost there. So I'm gonna ride with it as is. It's gonna be better than stock. There's no doubt in my mind about that. But you know, of course, my very first time doing a balanced crank, I want it to be perfect. But you know, sometimes you can't always get what you want. So look at this, guys. I started surfacing everything. Look at the intake. Now I just did it, I don't know, maybe 30 seconds on 60 grit, so it's fairly aggressive on aluminum. But look, it didn't even touch it here. So there's an air leak right there, right from the factory, and that's already for me surfacing it for 30 seconds with good pressure. So imagine how deep that was before I even started. Like, I mean, it's bad everywhere, like usual. Not touching here. Now, mind you, this side is slightly higher, I can catch it with my nail, than this side. So this will be down before this side. In the front, in the back, it's pretty much perfectly flush, but as you can see in the middle, we're not wearing, but we are wearing more over here than here, which means this outward side is very high. When I put it on a table, it rocked really bad. We're doing all right. It's not the worst I've ever seen, that's for sure. We'll get it down, but that's the biggest problem with this is I was worried how much I'm going to have to take it down to get a good mating surface, because I was originally not wanting to run a gasket. I'm going to have to run a gasket. By the looks of it, it looked like I might have to run 2 gaskets with an aluminum head gasket. Now I'm still thinking an aluminum head gasket, but I might have to go to 3 base gaskets to get the proper squish and height of the ports. Mainly because the surface is so bad. This is the last thing I gotta do for 60 grit, and then we're on to finishing passes. Okay guys, I'm turning you on for this because I really thought I wasn't gonna have to do this, and since I have to do it, I might as well turn you on for you to see. You saw that. Okay, this is the first one that I have put together. So I've come up with a couple things that did not work. This one seems to be working. So I got this piece of bracket so I can push up against it. Let's see how this goes. Let's take it out and see how it looks. Spacing, this feels same as stock. The bearing's nice and clean. I cleaned it. That's why I did this. I had to clean it all out. I just put it back together. I want you to take a look. I trued it also. It's still spinning down. The piston and everything with the 4 washers is still heavier. But I know it's hard to tell, but believe me when I tell you, it is so much slower spinning. It's only a little more I have to take off. If I had the right size drill bit, the drill bit I was using to do everything actually broke today when I was drilling through all the way on the one. It just broke on me. So I think if I was able to go up the next size like I'm supposed to do, that is just past 12. Oh, just past 12 there. Look how slow it takes off. It's where it's gonna stay, but it's pretty close. Can't wait to try this honestly, because if it was a completely stock setup and I didn't have the washers in there, it'd be pretty much perfect. But because I got the washers in there, it's slightly less. But for the first time ever, I'm very happy with it. That's it. I'm done for the day. Tomorrow is pretty much assembly.